Transformations are where you take a figure and you change its size, but you don't change its shape, you're just changing its size, and you result in something called a similar figure. Um, so here's an example of one. If I want to enlarge this blue triangle by a factor of 2, which means that this blue triangle, ABC, would become bigger by a factor of 2, which means every length of side would get would increase by 2. So copy machines do this, graphic artists do this where they enlarge things. So this is something we do. We can also shrink them. But this means, let's say I start here, let's say I move point A over here to A prime, and I'm going to make this same length here, but I'll make it twice. So 1, 2, 3, it's right now a length of 3 squares. So if I double it, it means that now a length of 6 squares. 1, 2, 3, 4, 5, 6. And that gets me up here to B prime, which then gives me where that new triangle goes, where the new vertex is, I mean. And this side A to C is 1, 2, 3 also. So that means we have to go 1, 2, 3, 4, 5, 6 to get over here to C prime. And then you can just draw your triangle. Notice you can think of it as taking a point here and going along that point and kind of think of projecting. So you're projecting from this point. Here's your length A, and you want to double this length, so you're going to go A and then A prime. You go 1, 2, 3, 4 to here, and then you go 1, 2, 3, 4 here to C prime. And same thing here, 1, 2, 3, 4, 1, 2, 3, 4 to B prime. So you kind of think of it as following along from that point and heading to these points and then continue that line on. It's another way to draw enlarged figures. You can also, again, make them smaller by the same kind of method. What it creates is a similar figure. A similar figure is a figure that has the exact same shape, but not necessarily the same size. But because it has the same shape, the side lengths and the interior angles are what we call proportional. So in other words, this angle right here is the exact same size as this angle right here. This angle here and this angle here are the same, this angle and this angle are the same. And that means the sides are in proportion. So if I took this side, which is length 7, and this side that's length 5, and took their proportion, 7 to 5, it'd be the exact same proportion as this length here, x, and this length here, 10. So I can create a 7 over 5 is equal to x over 10. So I create this equation right here. That allows me to now solve. So I can cross multiply the 5 over, the 10 over, 10 times 7 is 70, 5 times x is 5x, and then solve for the x by dividing both sides by 5. So I know that x is length 14. And you can see that in the exact same ratio. 7 over 5 is 14 over 10. A gnomon is a shape that is added to another shape such that the resulting shape is similar to the original one. So like here, if here's A, which is a rectangle, and I add some gnomon shape, some weird shape, it doesn't have to be a rectangle, it can be any kind of shape we want, to this A, the resulting rectangle, A prime, is the same exact proportions. It's similar figures. So even though this gnomon is not a rectangle, when I attach to this rectangle, I get a similar rectangle from the A. So A and A prime are similar to each other with this added gnomon. Again, the gnomon can be any shape. So here I've got a triangle. If I add kind of a, well, this one happens to be a parallelogram to this, I can get, actually it's not a parallelogram, it's just a quadrilateral. So it's a quadrilateral, I can add it to this, and I get a new triangle, A prime, that is similar to A. What's nice about this is we can actually solve some problems. So let's say I take a problem where I would like to find the value of x. So here's x, such that the red triangle on the right, so this red triangle on the right is a gnomon to the blue triangle on the left. So we're going to call this blue triangle A. This blue triangle has length 6, 6, and 9, so it's an isosceles triangle. I'm going to add this gnomon to it to create a new triangle. And this new triangle is similar to the original triangle A. So if we think of it as this side was 9, and let's say we added on this gnomon and we said that this side was also 9, and this side is x, so we now get this new triangle. we're going to kind of think of these all together of 9, 9. And this length here is the original 6 plus the new x. So it's 6 plus x. And if you think about this, this is also an isosceles triangle because we have two sides of the exact same. So again, two sides are the same, 6 and 6, and 9 and 9. So think of it as this 9 and this 6 belong together, this 9 and this 6 belong together, and this length here of 9 belongs with this side, 6 plus x. So think of it as which sides would be corresponding sides. So one way to think of it is the short side over the long side. So a short side is maybe the 6, the long side is 9 because it's definitely longer than the other. So in this triangle, the blue triangle, a short side is 6 and the long side is 9. In the green triangle, the short side is 9 because again it corresponds to one of these lengths here, and the long side is this 6 plus x because it corresponds to this long side over here. So we get 6 over 9 is 9 over x plus 6. So now you can again cross multiply. The 6 times 6 plus x is 36 plus 6x. The 9 times 9 is 81. And then you get an equation you can solve. Subtract 36 from both sides. 6x equals 45. Divide both sides by 6, and you find out what x is equal to. So in this case, x is equal to 7.5. Here's another gnomon example. We'll again start with our rectangle. Let's say we have a rectangle that's a 6 by 10. We're going to call it rectangle A. We're going to add this gnomon to it. We know this side is length x. We don't know what that length x is, but we're going to find it. And we know this length is 2. So we're creating this figure that we're attaching to this, that we know is in length 2 here, and we call it this length x, and we're trying to find out what x is. So we now have this triangle here, the A triangle, and this gnomon attached to it, and we get a bigger triangle, which we'll call A prime. And that bigger triangle, the long side here, 10 plus 2, is 12, and this length here is the 6 plus the x, so it's 6 plus x. Again, corresponding signs, this long side and this long side, we're going to call that the length, and this short side and this short side, we're going to call the width. Always make sure that you have length over length, length over width, so and length across from length and width across from width. So if you put the length of 10 from the original rectangle over the width of 6, you get one proportion, one ratio. If I put the length of 12 over the 6 plus x, the width, you get another ratio, and they are equal to each other. So that gets you your proportion. You can now solve these by multiplying both sides, kind of cross multiplying. So multiply 10 times the 6 plus x, which is 60 plus 10x, and the 6 times 12, which is 72. Then you just have a nice little equation to solve. So subtract 60 from both sides, 10x equals 12, divide both sides by 10, you get x equals to 1.2. When you set these up, always think of it as having length over width equals length over width. Or if you want width over length, it doesn't matter as long as you just make sure you got length across from length, width across from width. So let's take another example. In this example, triangles A and A prime are similar and are related by the scale factor of 5. If the perimeter of A is 42 feet, find the perimeter of A prime. We have A and A prime, we have two triangles. Remember, the perimeter is a distance all the way around. And so we know the distance around A is, if the perimeter of A is, let's say, 42 feet, so we know the distance all the way around A, find the perimeter of A prime. Well, again, each side is being multiplied by a scale factor of 5. So if you're going to have 42, you're going to have a scale factor of 5 on this side, a scale factor of 5 on this side, a scale factor of 5 on this side. So each side is going to have the scale factor of 5. So your perimeter, if you think about it, would be 42 times that 5, that scale factor. And that gives you 210 feet. Think of it again, if you draw a triangle in here, what that triangle would look like. And that triangle would have, that length would be 5 times. So you're multiplying this length by 5, this length by 5, and this length by 5. So remember, multiplication addition, you can actually factor out the multiplication. So over addition, you can factor out the multiplication, which is what has happened. So that's why the 5's there. Let's say the area of A is 68 feet squared. Then find the area of A prime. So it doesn't make sense if we multiply each length by 5. It doesn't make sense to just multiply 5 times the 68 feet squared, because you would think of it as area is usually length times width, or area of a triangle is base times height times 1/2. So we're actually multiplying that scale factor of 5 times that scale factor of 5. So you can have 5 times 5, 5 squared, times your area of 68 feet squared, which gives you 1,700 square feet. And that's how those all work.